Okay, now we'll discuss how to use TinkerCAD to run a motor using LDR. So whenever I say run a motor using LDR, so let us consider a motor. So let us consider this as a DC motor. So I want to run this DC motor with different speed that depends on the brightness of the light. So assume that this is motor. Now we know that DC motor can run if I apply a DC voltage. Suppose if I vary the DC voltage, then the speed of the DC voltage is proportional to the applied voltage. So this speed is proportional to the applied voltage. So what we do is, so we want to achieve different speeds for this motor. So using an LDR. So let me consider an LDR, which is maybe you can use this as a LDR. So this is LDR. This is a particular value of resistance, maybe 1 kilo ohm or whatever the value of resistance. So I will ground this. I will connect this to this, and I will connect a voltage V here. You can see I'm applying voltage to this entire network. Suppose if the property of the LDR is, suppose if this is LDR, we will have some resistance for the LDR. If the light falling on this is bright, if it is a bright light, then the resistance of the LDR is less, so it is less value. If it is dark in nature, if the light is dark, then the resistance is high. The resistance when the light falling on this is least, then we are going to get the high resistance. If you can see here, if I know what is this voltage, okay, instead of driving this directly, what I'll do is I'll put LDR and put a Arduino. I will read the analog value and I will out the analog value. So this is an Arduino. So of course we just want to utilize the Arduino so that we can try to understand how do I read the analog value and how do I write the analog value. Even if you are not using Arduino, it will still run the way how it is written here. So instead of just writing this wire directly, so let me connect it to A1 and then connect it to pin number 9 of the Arduino. So the value at A1, the analog value at A1 is corresponds to 5 into R of the LDR divided by 1 kilo ohm plus R of the LDR. Of course I can put this RLDR here or here. So if I put the RLDR up and this down, so then A1 becomes 5 into 1k divided by 1k plus RLDR. So this is the only difference. If I have this LDR they are placed on the, suppose if the values of if the position of R and LDR interchange, then this is the equation. So we will try to realize this using TinkerCAD. Let me just put TinkerCAD. Okay, here this is my TinkerCAD. Let me open that. Let me just open here. Give me 1 or 2 minutes. So I already rigged up the circuit. So we just spend some time in understanding how the circuit is written. So this is my DC motor with LDR. You can see this is we are trying to use the circuit which is already being created. Because this is circuit what you have. You can see there is a LDR. So this LDR is actually connected to ground. So it's exactly the way how we considered it here. The resistance is I think it is 10 kilo ohm. The resistance here, you can see this is 10 kilo ohm. Okay, you can change the value of that resistor also. Okay, fine. Here instead of 5 volt I have a 4.5 volt or you can use suppose if you want to use 5 volt only, what I can do is the other possibilities I can delete all of them. So I'm deleting this. So let me use this for okay, I can use the battery which is there for the demo. Okay, I can ground this. You can see I can okay, let me use this as okay, black one. Let me use this as red, and this junction, sorry, this now this is actually 10k. Okay, let it be 10k. Let us try to find out what is the resistance for this. Now it's connected to A1. Now you can see this is my DC motor. This is my DC motor to which the PWM output is connected to positive and negative is grounded. Let us have a look at the code. If you look at the code, you can see motor is connected to pin number 9 here, and there's an integer by name val is initialized to 0. And of course, since I want to use motor pin as output pin, I'm defining it as motor comma output. Serial dot begin is used to read the value of this A1. So you can say what we are trying to do is, so in the infinite loop, the value of analog value of A1 is being put onto val here. You can see val is equal to analog read 1 corresponds to the value that is coming on to A1 will be taken into val. That val value will be analog written onto this. So what we can do is you can certainly divide that value of val by 2 because whatever you're reading, sorry, divide by 4. So what I'll do is let me just divide this and then also write the new val. New val is equal to 0. This is one more integer I'm defining. So this is again an integer. Okay, now what I'll do is I will assign, this is what w val double equals val. Okay, now I'm putting the value of, and let me write, okay, not this val itself, let me just divide this by 4 and do it. Divide by 4 and then okay, this is this should be new val. New val. Okay, now your, because whatever red value will be using a 10-bit ADC, so I want to divide by 4 so that I can write it in 8-bit DAC. Okay, let me read the value of this val here. Okay, otherwise let me write it as new val itself, new val, and this is val. If I run it now, you can see now it is running. Let me see the serial monitor value. Okay, now serial monitor value is showing me 0. I can actually change the, okay, let me see what is value from assigned to this. Okay, let me stop this. I can actually run this. Okay, so there is some issue with this. New val is getting new val is should be 1 equals, this should not be 2 equals because you're not checking the value, you're simply assigning it. Run it now. Fine. Now you can see Now you can see the value that is there coming is 242, which is almost equal to, you can see the speed is almost running at a very high speed of 5000 rpm. So what I'll do is let me just change the, see when I just increase this, can you see this is coming down? So why this comes down is, you can see the motor speed also has reduced. So now when it becomes brighter, the resistance of this LDR will reduce. When the resistance of the LDR reduces, then the voltage at A1 will reduce. When the voltage at A1 reduces, naturally the voltage that is given to the motor will also reduce. So that's why it is running at a lower speed. Suppose if I make it much more brighter, you can see this value is almost very less. Now you can see motor is almost running at a very small speed of almost 300 or 250 rpm. Now this way we can able to change the okay, what I'll do is let me just zoom this closer to, let me just bring it closer here. Let me start the simulation. Okay, 1 second. I want to just bring both of them close to each other so that we can able to increase them. Okay, now let me run this. You can see this is running at highest speed. This is almost 5000 rpm. You can also see the simultaneous value of this. You can see it's almost running at high speed. 255 is the maximum value. You're getting almost close to that. Now you can see as I increase this value reduces. So this value reduces, naturally the speed of the motor also reduces. You can see speed of the motor is also reduced. Let me just take this. Wait. Let me take this. Okay, stop this. Let me take this slightly. Okay, fine. Let me run it now. You can see now as I make this, can you see it is speed is keep reducing. Speed is keep reducing as I make this brighter and then make this brighter. So this way we can able to use the LDR for changing the motor speed, where you are reading the analog value and then writing the analog value onto this particular pin. So we will also see one more experiment using relays in the next video.